Alrighty, let's talk about isotopes. Let's get some more parts of the atom under our belt here as we think about some things here. Um, First, before we dive into that, let's think about elements in general. All right, we said at the very beginning of all this that elements are a pure substance, but they can't be broken and they can't be broken down by chemical means. Okay. Now we have a more modern definition now that we know what atoms are made of. So we can say, yes, all atoms are chemically the same, right? That's kind of what Dalton was getting at too. Um, but we can also say all atoms have the same number of protons, and not all atoms, but atoms of an element all have the same number of protons. So this is kind of how we define elements as of now. Um, and we've even defined this number of protons as its own number called the atomic number, and we call this Z. Okay. Um, and as you probably already know, we often refer to elements by their symbol um, in writing formulas and such. And you've already seen some of those during the other videos, I'm sure. So you will get a handout like this in class. This guy right here. Um, there are 118 known elements right now. I'm gonna make sure that you know the names of 52 of them, some of which you already know, right? But we have to know names, we have to know symbols. What's important to get about the element symbols is that all of them are one or two letters. If there are two letters, the second one is always lowercase. Okay. Most of these make sense when we think about English, um, like H for hydrogen, Br for bromine, C for carbon, F for fluorine, uh, lots of these. Aluminum is Al. Okay. Many of these don't make sense with regards to English, like Na is sodium, or Fe for iron, and K is for potassium, uh, and Cu for copper. There's there's a bunch of these. Uh, Sb is antimony, and Pb is lead. So there's a whole host of these. Um, these come from Latin names. Okay, that I don't know what that says. Okay, so I'm not going to make you know Latin names, but I want you to know what the symbol goes with the English name of stuff. Okay, there's one of these non-English names that's not Latin and it's German, and that's W. W is tungsten, and it stands for Wolfram. Um, so there we go. Okay, what we gotta get out of this? The atomic number. Also, the atomic number always shows up on the periodic table. Okay, so and we also know the periodic table is arranged by atomic number, so that helps us keep things straight as we do that. Okay. What we want to dig into here, isotopes. And isotopes are all atoms of the same element with different numbers of neutrons. So they all have to have the same number of protons or they're not the same element, but they can have different numbers of neutrons because the neutrons don't have anything to do with the identity. They're only there to help hold the nucleus together. Okay. And when we think about counting neutrons, we count them, well, the same way we count other stuff, but we represent this as a mass number. We call this A. Um, and the mass number is the total number of protons plus the total number of neutrons. Okay. Um, and so the mass number refers to the total number of particles in uh, the particular nucleus of an isotope that we're looking at. Okay. Um, I've lost my click. There it goes. Okay. So when we're thinking about isotope symbols, it's one extra layer of information beyond just the atomic symbol. Okay, so if we look at this, this is our generic format. X here is whatever our atomic symbol is. I'll work some examples of these as we go too. Okay, A here, we just saw this is our mass number, and Z here is our atomic number. Okay, and so it sets us up to be able to figure out neutrons quite easily. So if we said, for example, we have 20 over 10 Ne. Okay, this is a neon atom. Okay, and the neon has a mass of 20. Okay, we can refer to this a lot of different ways. We can say this is neon, this is the full symbol. Sometimes when we type things out, we'll just say Ne-20. We'll use the mass number to tag with it. You could say it's neon 20, or you could just leave off the atomic number. Okay, because sometimes it's hard to type those stacked things, but all of these things mean the same thing. It's a neon atom that has a mass of 20. Okay, if you want to figure out what the different particles are, remember atomic number is number of protons, so that's protons. This is total. So to get neutrons, we're just going to subtract 10 from 20 is 10, and that's how many neutrons are there. Okay, so we can always figure this out like that. Okay. I think next is, okay, yeah. Hydrogen has 3 isotopes that we deal with regularly. Most hydrogen just is a proton and an electron. It's named protium. We never call it protium. We just call it hydrogen. But there's deuterium and there's also tritium. And deuterium is often referenced as D and tritium is referenced as T, just as a shortcut because we use them, well, deuterium especially, but we use them quite a bit. We're not really going to mention them much more beyond that. All right, so here's a question. Let's see. A particular atom has 28 protons and 31 neutrons. We want to write its isotope symbol. Okay. So what we know off the bat, remember we have to do A over Z and figure out what the element is. Okay, so we know we have 28 protons. Okay, we'll probably want a periodic table for this. No, I didn't have to write that down. So here's a periodic table. So we want to figure out what element is number 28. So we're going to dig through the periodic table. Here's 28 is nickel, so we'll give it nickel. Okay, the atomic number and the element symbol always go together. So 28 is always nickel and nickel is always 28. Our top number here is protons plus neutrons. So 28 plus 31 should be 59. Yeah, I had it in my head. Good job. All right, does that make sense? Wait, let me go back. We can also do it the other way around, right? If we have, and we've done this before, but if we said, I don't know, what do we have? PB82 and 208. There we go. Okay. How many protons, neutrons, and electrons are in that atom? Okay. Well, we know that there's 82 protons because that's the atomic number. We know, now this one I'm not going to do in my head because I'm tired, but I just made it up. 208 minus 82 will give us neutrons. There's 126 neutrons. What about electrons? Okay, if we know this is a neutral atom, then we know it has no charge. And because of that, excuse me, the number of neutrons, the number of electrons has to equal the number of protons. So this should be 82 electrons. Okay. Now, if we're not dealing with something that's a neutral atom, then we're dealing with an ion. Okay. An ion has a charge. Okay. It has a charge because it doesn't have the same number of protons and electrons. Okay. They're going to behave chemically different than the neutral atoms. Okay. There's a lot of chemistry in here that we're going to dig into throughout the course. What I'm getting at here is we're just going to introduce this idea of ions so we can deal with it later too. Okay. They have unequal amounts of protons and electrons, and this happens because they've either gained or lost electrons. Okay. So things to remember here, cations have a positive charge because they've lost an electron. Remember, electrons are negative. So a positive charge lost electrons. Okay. And one way to think about this, cations are positive. I found this and just thought it was ridiculous. So there we go. The flip side of this, anions are the negative charge ones. Okay, they're negatively charged because they've gained electrons. So, for example, if we're going to make a cation, right, that would be that we say we have we have a sodium atom and it has lost an electron, and now I will show Ne. Now it has a positive charge, and we say it lost its electron. Okay, we'll get into these more as we go, but when we talk about ions, we put the charge as a superscript as we do it. Okay, um, and then if we have an anion, right? Say we have a chlorine atom and it picks up an electron, then it turns into a Cl minus ion, and we have the anion or the chloride ion. Okay, we'll talk a lot more about ions and forming ions and why and how that happens as we do stuff later on in the semester. Okay, if you need me, you know where to find me. I will catch up with you later.